Hi everyone and welcome back to Matter for Thought. Today I have another guest. GreaterSapien, you can take it from here.
As promised in the previous episode, today we will see what happens when you want to represent the location of an object that does not remain in its place. In a situation where we have an object whose position changes over time, the only way, of course, is to introduce time into representation as well. And this is how we get a complex physical distance over time, or in other words, speed. Speed is a physical unit that is not new to anyone here, and there is really no need to expand on what speed is exactly. So, in a nutshell, just like any division operation, if I know that between the starting point and the destination there is, say, 60 miles, and I have covered this distance, say in 2 hours, then how many miles does each hour get? So, after we made that clear, let's leave that and talk about the phenomenon from which speed is derived: motion. Motion is basically the change over time of the location vector as we saw in the previous episode. There are several types of motion, and we will cover all of them as the series progresses, but today we talk about motion at a constant rate. Because time is a directionless physical unit, velocity, which is a center for time, is also a vector. As a result of this insight, we can define the direction of motion, i.e., where the object is progressing, and its magnitude, i.e., how fast it is moving. And just because we are already used to seeing everything on the board, let's draw it on a 2D axis system. Just one more thing before proceeding. There are two types of speed: speed with direction and directionless speed. Speed with direction describes exactly how fast and where the object is progressing, and it is a vector called velocity. Directionless speed only describes the magnitude of the velocity, and it is not a vector. The magnitude of the vector, by the way, is indicated by the sign of absolute value. For convenience, we will place the starting point at the source, but this is not a requirement in every situation. Let us take the velocity vector of 1, 1, which means that our car goes 1 meter to the east on the x-axis and 1 meter to the north on the y-axis in each 1 unit of time, which, as we mentioned in the first episode, is 1 second. What we've got is motion with the velocity size being the square root of 1 plus 1, which is about 1.4142 meters per second, and heading exactly northeast. Just as in a location description, velocity can come in 3 dimensions and not just 2. Instead of a car, we can talk about a drone that can change its elevation as well. The principles remain the same. In each unit of time, the drone advances on the north-south axis, the east-west axis, and the up-down axis. In the next episode, we will introduce another concept, which means matching two physical sizes with dependencies. And we will talk about how to mathematically represent things that are changing in general, and things that are changing position over time in particular.
GreaterSapien, thanks a lot. That was incredible. And that's for today, friends. You're all more than welcome to go to GreaterSapien's channel and subscribe. He's an omni-content creator. A link to his channel is in the description. Before I wrap things up, I want to thank my patrons. Their names are running currently on the screen. Feel free to like and share, and subscribe if you haven't done so already, and leave a comment. I was, as always, rndthinker, and see you in the next video.